Welcome to Bold Guy DIY. In this video, I'm going to show you how to change a receptacle safely in your home without curling your hair. And for me, that's really saying something. So we all know that electricity has the potential to be dangerous, even life-threatening under certain circumstances. And so one of the questions I often get from people is, what's safe to do if you're not an electrician? If you don't have the training and knowledge necessary, how do you know what's safe to tackle and what's not for projects around your home? Generally, I don't recommend anything that requires taking apart different connections, rewiring things, or adding functionality that wasn't there in the first place, because there's a certain amount of knowledge and experience necessary to do that properly and avoid any potential problems. When it comes to changing something like a receptacle, most of the work's already been done because the original connections have been made. It's simply a matter of swapping one device for another. Of course, there are still risks and hazards, so I'm going to give you some techniques, advice, and knowledge so that you can understand how to change a receptacle safely and have it all work out well in the end. So let's get started. The first thing that I want to show you is just what a standard receptacle looks like. These are called duplex receptacles, and they're available in either this standard round shape or in these square or rectangular decorator or decora style. The rating on them is 15 amps, which is the standard circuit for homes in North America. Now, because of that, they're really the same internal components. You know, everything is rated for 15 amps total for the device, and as long as you stay within that, either one of these, it's mostly a matter of preference, what style matches your home. I personally like the decorator style more, but it's kind of up to you. Now, the first thing you're going to see is that there are 3 different holes for 3 different pins of a plug. Each of those pins actually has a different role and a different configuration, and so as we go through it here, I'm just going to explain what those are. The most obvious one is the one that looks quite different. That is the ground pin, and that one is tied directly to that bare copper wire that you find inside an outlet box, and that's going to be tied to the ground of your entire home and the electrical system. The other 2 slots are designed, one for what we call the hot or live wire, and the other one which is for the neutral or identified conductor. What does that really mean is that on the one that has the smaller type vertical slot, that's going to be the hot or live, and the wider vertical slot is going to be for the neutral or identified wire, we call it. One of the questions I get from casual homeowners is if those pins really matter, because of course it's 120 volts across the 2 vertical pins regardless of which wire goes on which. That's absolutely true. However, the reason that it matters which vertical pin you hook the live wire to or the neutral wire is because the devices that you plug into those things are designed to switch the live wire. According to the electrical code in Canada, and I believe also the NEC in the United States, is that you always want to be able to turn off the power to the live conductor. The reason for that is that whenever you have your device, when you turn your device off, even if you were to take it apart, beyond the switch, there wouldn't be any live connections. On something like a lamp, for example, if you were to turn off the lamp's switch, you could stick your finger in the socket where the bulb goes and it wouldn't be dangerous because the switch has turned off the live wire. If the receptacle is wired incorrectly, or if the plug's inserted backwards, then what could actually happen is even when you turn the switch off, there could still exist a connection between the live wire and ground. If you stuck your finger inside the socket where the bulb goes and then happened to touch something that was grounded, you could actually create an electrical path through your body, and it could lead to electrocution. So it's very important that we follow the conventions of the electrical code, because if we do all of those things consistently, we have a safer end result. As we look at the actual terminals on the receptacle, we find that there are brass or gold colored screws, there are silver colored screws, and then there's a green screw, which is for the ground or bare copper wire in the outlet box. Each of those has a specific purpose, and they connect to the pins that I've described before. The bare copper wire is going to be connected to the green screw, and that's going to be connected to the outer metal housing of the receptacle. If you're to touch the mounting hardware of the receptacle and be connected to the live wire, there's going to be a ground circuit there, and that's there to protect you, that if you were to touch some part of the box to the live, it will immediately trip the breaker because there's a lot of current that's going to flow. The neutral wire, or identified wire as it's called in the electrical code, is there to give the return path back to your panel, and the hot wire or live wire is the one that brings power or electricity to the receptacle. Typically your live wire is always going to be black, although occasionally it could be red in your home. So it's important to understand that the live wire is going to connect to the brass colored screws, and the neutral wire is going to connect to the silver colored screws. It's very important to understand that, as I said before, if you reverse them, the receptacle will still work, but for the sake of safety and convention, it's important that the live wires go to the brass colored screws and the neutral wires go to the silver screws. If you look at the back of a receptacle, you'll also see near the screws that there are holes there, and those holes exist in order for you to stab or push in bare copper at the end of those conductors in order to make the circuit without having to twist loops that go around the screws. Now those holes are rated and determined by the manufacturer to be just as good as making the loops, but for a couple of reasons I'd really prefer to use loops around the screws than use those stab or push holes instead. The first reason that you don't want to use those pushed in connectors or stabbed in connectors is because they're sometimes difficult to remove the wire from. Now some receptacles do actually have a little release button that you can push, but for a lot of them it's going to require you to either pull it out with some pliers or to cut it off flush. And when you do that, it's going to shorten the wire. And so every time you'd replace the receptacle or work on it, you're going to shorten the wire more and more. Eventually it's going to become very difficult to have enough wire in the outlet box in order to do a replacement. Now of course we don't change receptacles all that often, but in the case that we have to, it's better to be able to keep the same length of conductor without shortening it every time. Also with the stabbed in connector, it's difficult to know exactly how much you should strip. There is a strip gauge on the back of the receptacle that tells you how much of the insulation you should take off, but if you're not careful, you might either have too little stripped off, which might not make a complete connection inside the receptacle, or too much, which is going to leave some exposed copper, which could lead to a short if another wire or dust or debris would build up on it over time. The preferred method is to bend the ends of the wire into loops and loop those around the terminals so that the loop is in a clockwise fashion. That way, as you tighten the screw, it causes the loop to close tighter and tighter, as opposed to if you put it on counterclockwise, it's actually going to open the loop as you tighten it down. Before I show you the steps to actually change the receptacle, there's one more thing that I want to talk about, and that is that the top and the bottom receptacles have the ability to either be used together on one circuit or separated into two. As you can see here, there is a little tab that joins the top and bottom screw on both the brass and silver screws, and so if we leave that tab in place, it means that both of those receptacles are joined together. If we break the tab and open the connector, then it actually separates those top and bottom receptacles so that they're on different circuits. That can be really important because there are applications in your home that use two different circuits. One of those applications is in counter plugs in your kitchen, which might use separate circuits for the top and bottom receptacle in order to prevent the circuits from being overloaded by high power devices like toasters, blenders, that kind of thing. So if you're looking at removing and replacing a receptacle, it's important to check the existing receptacle and make sure that you know whether or not the tabs have been broken. If they're broken on the original, then they should be broken on the replacement as well, because that means you're going to need two separate circuits. If you leave the tab in place when it's supposed to be removed, you're going to create a short circuit between the top and bottom live wires, which is going to definitely trip the breaker. That much heat could also damage the new receptacle that you're putting on. And even in one case that I heard of, a friend of mine tripped his neighborhood's power because the dead short, when he went to reset the breaker, actually ended up taking out the neighborhood's transformer. To avoid all of that, make sure that you check those tabs, whether or not they're supposed to be broken or joined. In most cases, the tab's going to be in place, and it's going to be a single circuit for each duplex receptacle. But in many cases, in a kitchen, or possibly in another place where there's one receptacle of the two that is switched by a light switch, then those kind of situations could have the tab broken. Keep an eye out for them and make sure you don't short circuit the top and bottom if they're not supposed to be. With that background out of the way, let's talk about the actual replacement of a receptacle. Now, in a previous video, I did show you how to test for voltage, and that information is very helpful when you talk about making sure that the power has been turned off to a receptacle. An electrician or someone who understands what's live and what's not and understands the risks and some of the safety equipment that can be used to avoid those risks might consider replacing a receptacle live. But for someone who's inexperienced, I would definitely recommend turning off the power to that receptacle before you try to replace it. If you have a plug tester or another way of checking voltage, make sure to test that and turn off the breaker either to that individual circuit, making sure that once you've turned it off, there's no more voltage present, or by turning off the main breaker to your home, which will put everything in the dark. If you're doing this at night, of course, you'd need a flashlight or something like that to be safe. Once you've turned off the breaker and you're sure that it's isolated, check it again anyway. Use your voltage tester on both receptacles and make sure that neither one of them shows any voltage. Once you're sure that the receptacle is no longer powered, you can remove the cover plate and then the 2 screws underneath, which will release the receptacle from the outlet box. You want to make absolutely sure that you've turned the power off. Once you've done that, you're going to take a look at the existing receptacle and see how it was connected before. You would definitely expect to see all of the white wires connected to the silver screws and the black or red wires to be connected to the brass screws. If that's not the case, I would advise you to stop right there and consult an electrician because there's something wrong with the wiring. As long as the black or red wires are going to the brass screws and the white are going to the silver screws, and of course the bare wire or green wire is going to the green screw, then you know that the original receptacle was probably connected correctly. Then you can proceed by removing the connections from the original receptacle and transferring them to the new receptacle. Of course, as I said, if you have the stabbed or pushed in connection, you may need to trim those as there may not be a release button in order to let those conductors free of the receptacle. Remove the conductors from the receptacle, transfer them to the new receptacle, and it should be just that simple. If you replace the wires in the same position on the new receptacle that they were on the old, you're going to be safe and sound like it was before on the previous receptacle. This is also a really good time to check for those tabs and make sure that they haven't been broken on either the brass or silver side of the terminals. If they have been broken, it's really important that you put the same wire on the same position as it was before. Don't mix them up. It would be possible to hook the neutral from one circuit to the live from another if you're not careful. And in most cases, it would probably still work, but for the sake of consistency, you want to make sure that you're using the neutral and the live wire from the same circuit. So if those tabs have been broken, it's really important to make sure you know which wire goes to which terminal. If the tabs are intact, then as long as you put the live wires on the brass screws and the neutral wires on the silver screws, everything should be all right. While you have the wires pulled out of the outlet box, it's also a good time to inspect the jacket on the wires, make sure that it hasn't been cracked, scraped, cut, or broken, and the wire is not exposed. After you've made all your connections and you're ready to put it back together, it's important to put the wires back into the box in a way that the exposed bare copper wire is not going to be touching any of the terminals. That's the way you get a short circuit. So you want to make sure that the bare copper wire is especially away from the terminals, and then bend the wires in such a way that they kind of accordion or fold back into the outlet box as you push the receptacle flush with the outside of the box. All you need to do to put it back together is fold those wires in carefully and then tighten the 2 screws that fasten the receptacle to the outlet box. At this point, it's also a good time to check to see that the receptacle looks straight and make any adjustments, because you can loosen and tighten the screws as needed to give yourself the ability to move it and slide it easily. When you put the cover plate back on, you might find that it's still a little out of alignment, and there's a few things that you can do. You could tap the opposite corner with a screwdriver and a hammer or a set of pliers in order to give it just a little bit of a bump and straighten it out, or sometimes it's enough just to put your hands on either side of it and just give it a little twist. One of the other problems that occurs when you're trying to align everything is that the receptacle might not be sitting quite flat inside the cover plate, and it might kind of be turned a little bit to one side. Now there's a few ways that you could try to do that. You could try to take the cover plate off and readjust it and everything. But one of the things that you can do, you put a small screwdriver or awl into the ground pin and just give it a little twist. We don't want to put a lot of pressure on or really force it, but by giving a little bit of twist like that, it'll straighten out. And of course, by using the ground pin, we're not introducing any possibility of electrocution or a short circuit. Once the cover plate's in place and the installation is done, you can turn the breaker back on and test again for voltage on both receptacles to make sure they're working correctly. If the breaker immediately trips, you know that there's a problem and you have a short circuit somewhere there, so make sure the breaker is off and then inspect it again to see where the problems are. If you follow the instructions from this video, I'm sure that you'll be able to identify it or see that there might be a pinched or scratched wire that's creating a short circuit. That's basically all that you need to know in order to safely change a receptacle in your home. Remember, more than anything else, to identify which breaker controls that receptacle and to make sure that it has been turned off before you go working on it, poking in the outlet box, or anything like that. I hope you found this video helpful, and if you've got ideas for other questions you'd like answered, feel free to leave them in the comments or send me an email. My information is in the description below. I really love being able to share my knowledge and experience with electricity, and I hope that it can benefit you. If you like these types of videos or any of the other projects that I've done, please consider subscribing, ring the bell to be notified of future videos, and check back regularly as I post a new video every weekend. Until next time, when it comes to electricity in your home, don't be afraid to be bolder and tackle some of those projects, but be sure to stay safe and practice responsible use around electricity.